Hello, I'm Dr. Michael Scriny, and welcome to the DCU School of Computing PhD Research Series, where each week we take one PhD student and ask them who they are, what's their work about, and finally, why is their research important. And this week we have Vitor Horta to talk to us about explaining deep learning models through graph analysis.
Hi, I'm Vitor Horta, and I'm a second-year PhD student at DCU. And my research is funded by Science Foundation Ireland and a collaboration between Nokia Bell Labs and Amsterdam Data Science and the Insight Center for Data Analytics. I started my career as a software engineer, and after working in several companies, I decided to start a master's degree in computer science at the Federal University of Juiz de Fora in Brazil, where I did research on social network analysis, and we proposed an algorithm for detecting, for example, influential people and groups of people in social networks. So after that, my co-supervisor got this PhD position, and she thought that I might be a good fit for it. And I was offered this PhD position at TCU under the supervision of Professor Alessandro Mileu. And then I moved to Ireland in the beginning of last year to begin the PhD. My research is in the field of explainable AI, which is a field that tries to explain and understand how artificial intelligence models make their decisions and how is the thinking process of these AI models. So this is a field that is getting a lot of attention from researchers because AI is becoming more and more present in our society. So if you are relying on AI to do some complex and relevant and solve real world problems for us, we need to understand how they think and understand the decision-making process. So because these models, they learn by themselves, we don't explicitly program them, it is difficult for us to go and look inside the architectures and the representations and understand what's going on inside them. And there are billions and many calculations and parameters, so it's very hard for humans to interpret those models. So I'm proposing a methodology that's based on the graph analysis and inspired by studies in neuroscience to understand the internal workings of those, especially deep learning models. And we think that we can, since deep learning itself is inspired by neuroscience, we think that we can take advantage and benefit from these methods that studies and try to explain the structure of the brain to also explain the inner workings of these models. So what we are doing is to build a graph that connects neurons based on the correlations of the activation values. And then once we have this graph, we can mine it to find, for example, communities of neurons that act together, or what are the most important parts of this neural network for achieving particular decisions. And for this, we can gain and understand and gain some insights on why the model makes some particular decisions and to predict the behavior of the model under certain circumstances that might be important for the problem it is solving. So my research is important mainly because of the presence of AI in our society. So we know that we can use intelligent agents to perform complex and critical tasks for us and solve real world problems. And we have examples for this. For example, like we have machine translation and have very critical things like medical diagnosis and self-driven cars. Then they all can benefit from AI. And but if you want to use AI for such purpose and in large scale and solve those meaningful tasks for us, we need to be able to understand how they're thinking and to understand the decision making process in a whole basis. So we need to be certain of certain behaviors they might do under certain circumstances to guarantee that some undesired behaviors, for example, will not happen. In one example, the ethical guidelines for trustworthy AI states that AI needs to be ethical, lawful, and robust. But the way it is today is very difficult to meet these requirements if you don't understand the internal workings of those models. So to meet requirements like this and guarantee to people that they can fully rely on those models. We need to have more control over these models and understand how they think and what's their internal structure. And I believe that my research is an important step towards this goal, because the method that we are proposing is really trying to figure out the internal workings of those models and explain in detail how those models are making particular decisions, so that we can understand where the model might fail and we can predict when we can really rely on the decisions made by AI and deep learning models.